Hi there, and welcome to my quiz channel. I'm Dr. Quiz. Welcome to the quiz. Today's topic is mathematics. Today, you have 25 questions. And now the rules. Pick your answer before the timer ends. The answer is revealed after each countdown. And keep score. Easy questions are 100 points, medium 200, and hard 300. Let's begin. Which curve is plotted? The choices: A. Hyperbola, B. Parabola, C. Circle, D. Ellipse. Think twice before you choose. Time, 10 seconds. Don't stall. Cards on the table. The answer? No doubt parabola. The image shows a single, smooth, U-shaped curve produced by a quadratic Bezier segment, the graphical form of a parabola, the locus of points equidistant from a focus and a directrix, or equivalently, the graph of a quadratic function. Which polyhedron is depicted? Take a look. A. Cube, B. Tetrahedron, C. Octahedron, D. Dodecahedron. This one trips a lot of people. I'm counting 10 seconds. The ones who picked it were right. None other than cube. The image shows a solid with 6 square faces, 12 edges of equal length, and 8 vertices where 3 squares meet. The regular hexahedron, more commonly called a cube. It is one of the 5 Platonic solids. Which famous numerical pattern is this? Options: A. Fibonacci pyramid, B. Sierpinski triangle, C. Number pyramid, D. Pascal's triangle. If you know it, you'll know it instantly. You have 10 seconds. Timer starts now. And the correct answer is... That's Pascal's triangle. The image shows the triangular array of binomial coefficients. Row n contains C of n0, C n1, dot C n. Each entry equals the sum of the 2 entries directly above it. The pattern is named Pascal's triangle in the West after Blaise Pascal, though it was studied earlier by Yang Hui, Al-Karaji, and Khayyam. The diagram shows the classical visual proof of which theorem? Choose. A. Euler's identity, B. Thales' theorem, C. Pythagorean theorem, D. Fermat's last theorem. Don't let the lookalikes fool you. 12 seconds on the clock. Go. Drum roll. The right one. Precisely. Pythagorean theorem. The diagram shows a right triangle with squares constructed on each of its 3 sides. The standard visual proof that the square on the hypotenuse equals the sum of the squares on the 2 legs, i.e., a squared plus b squared equals c squared. This is the Pythagorean theorem. What kind of arrangement is this 3 times 3 number grid? Your options: A. Magic square, B. Sudoku puzzle, C. Latin square, D. Number grid. Trickier than it first looks. That's 12 seconds. Timer's running. Moment of truth. The answer? It's magic square! The grid contains the digits 1 through 9 arranged so that every row, every column, and both main diagonals sum to the same value, 15. Such an arrangement is called a magic square. The 3 times 3 case shown is a rotation of the classic Lo-Shu magic square. Which self-similar fractal is shown? What's it going to be? A. Cantor set. B. Sierpinski triangle. C. Menger sponge. D. Koch snowflake. For the experts, this is a warm-up. 12 seconds to think. Start. Let's check. The correct one, of course, Sierpinski triangle. The figure is produced by starting with a filled equilateral triangle and repeatedly removing the central open subtriangle of each remaining piece. The resulting self-similar set is the Sierpinski triangle, or Sierpinski gasket, named for Wacław Sierpinski. What one-sided surface is shown in this photograph? The choices: A. Torus, B. Klein bottle, C. Trefoil knot, D. Mobius strip. Dig deep. The answer is close. Time: 12 seconds. Don't stall. Eyes on the screen. The answer? Yes, Mobius strip. A paper strip joined with a single half twist forms a surface with only one side and only one boundary curve. It is the Mobius strip, the simplest non-orientable surface, discovered independently by August Ferdinand Mobius and Johann Benedict Listing in 1858. Which topological surface is shown? Take a look. A. Sphere. B. Mobius strip. C. Torus. D. Klein bottle. Stay calm, no panic. I'm counting 10 seconds. Now we find out. It's exactly torus. The image shows a donut-shaped surface of revolution obtained by rotating a circle in three-dimensional space around an axis coplanar with, but not intersecting, the circle. This surface is the torus. Which famous fractal set is depicted? Options: A. Julia set, B. Mandelbrot set, C. Newton fractal, D. Lyapunov fractal. Sounds easy, but don't rush. You have 12 seconds. Timer starts now. Who got it? The answer? No doubt, Mandelbrot set. The image shows the set of complex numbers C, for which the iteration z under care n plus 1 equals z under care n squared plus c, starting from z under care 0 equals 0, remains bounded. Its characteristic silhouette, a large cardioid attached to a circular bulb with numerous smaller satellite copies, is the Mandelbrot set, popularized by Benoit Mandelbrot in 1980. Which named spiral is shown in this image? Choose. A. Archimedean spiral, B. Cornu spiral, C. Fibonacci spiral, D. Hyperbolic spiral. Easy to slip up here. 12 seconds on the clock. Go. No more waiting. Correct. None other than Fibonacci spiral. The figure is built by tiling the plane with squares of side length 1, 1, 2, 3, 5, 8, 13, 21, 34, the Fibonacci numbers, and drawing a quarter circle in each square. The resulting curve is called the Fibonacci spiral and approximates the logarithmic golden spiral whose growth factor is the golden ratio phi. Which 18th century mathematician is portrayed in this painting? Your options: A. Isaac Newton, B. Gottfried Wilhelm Leibniz, C. Pierre-Simon Laplace, D. Leonhard Euler. A classic everyone should know. That's 12 seconds. Timer's running. Cards on the table. The answer? That's Leonhard Euler. The painting is Jakob Emanuel Handmann's 1753 portrait of Leonhard Euler, 1707 to 1783, the Swiss mathematician who introduced much of modern mathematical notation, including f of x, e, I, and sigma, and made foundational contributions to analysis, number theory, graph theory, and mechanics. The diagram illustrates which classical problem in mathematics? What's it going to be? A. 7 bridges of Königsberg. B. Peterson graph. C. Utility graph K33. D. 4-color map. Now this gets interesting. 14 seconds to think. Start. The ones who picked it were right. Precisely, 7 bridges of Königsberg. The schematic shows a river with 2 islands connected to each bank by a total of 7 bridges. The layout of the Prussian city of Königsberg, modern Kaliningrad. Leonhard Euler proved in 1736 that no walk crosses each bridge exactly once, and his solution became the origin of graph theory and topology. Which classical fractal is this figure? The choices: A. Sierpinski gasket, B. Menger sponge, C. Koch snowflake, D. Mandelbrot set. Think twice before you choose. Time, 12 seconds. Don't stall. And the correct answer is... it's Koch snowflake. The figure is generated by starting with an equilateral triangle and repeatedly replacing the middle third of every edge with 2 edges forming an outward-pointing triangular bump. The limit curve, described by Helge von Koch in 1904, is the Koch snowflake, a bounded region with infinite perimeter. Which non-orientable closed surface is shown by this 3D immersion? Take a look. A. Torus, B. Klein bottle, C. Mobius strip, D. Sphere. This one trips a lot of people. I'm counting 12 seconds. Drum roll. The right one. Of course, Klein bottle. The image shows the standard 3-dimensional immersion of a closed, non-orientable surface whose interior and exterior cannot be distinguished. The Klein bottle, described by Felix Klein in 1882. In 4 dimensions, it can be embedded without self-intersection. In 3, the classical rendering shows the neck passing through the body. Which 19th century mathematician is portrayed here? Options: A. Bernhard Riemann, B. Augustin Louis Cauchy, C. Joseph Fourier, D. Carl Friedrich Gauss. If you know it, you'll know it instantly. You have 12 seconds. Timer starts now. Moment of truth. The answer? Yes, Carl Friedrich Gauss. The painting is Gottlieb Biermann's copy, after Christian Albrecht Jensen, of the standard portrait of Carl Friedrich Gauss, 1777 to 1855, whose contributions span number theory, algebra, statistics, analysis, differential geometry, geodesy, magnetism, astronomy, and more. Which Platonic solid is shown? Choose. A. Dodecahedron, B. Icosahedron, C. Octahedron, D. Tetrahedron. Don't let the lookalikes fool you. 12 seconds on the clock. Go. Let's check. The correct one. Exactly. Dodecahedron. The image shows a convex polyhedron with 12 congruent regular pentagonal faces, 20 vertices, and 30 edges. The regular dodecahedron. The only Platonic solid whose faces are pentagons. Which 20th century mathematician and pioneer of computing is shown? Your options: A. Kurt Gödel, B. John von Neumann, C. Alan Turing, D. Alonzo Church. Trickier than it first looks. That's 12 seconds. Timer's running. Eyes on the screen. The answer? No doubt, Alan Turing. The photograph, taken by Elliot and Fry in 1951, shows Alan Turing, 1912 to 1954, the British mathematician whose 1936 paper introduced the Turing machine and formalized computability, and who led decisive work on breaking German ciphers at Bletchley Park. True or false? Fermat's last theorem, the statement that x positive n plus y positive n equals z positive n, has no positive integer solutions for any integer n over graded 2, has been proven. What's it going to be? A. False. B. True. For the experts, this is a warm-up. 10 seconds to think. Start. Now we find out it's none other than true. Fermat's last theorem was famously left unproven in Pierre de Fermat's 1637 marginal note. It was finally proved by Andrew Wiles, with a corrected argument in a joint paper with Richard Taylor, published in the Annals of Mathematics in 1995. Which named plane curve is drawn? The choices: A. Lemniscate of Bernoulli, B. Limousin of Pascal, C. Asteroid, D. Cardioid. Dig deep. The answer is close. Time: 14 seconds. Don't stall. Who got it? The answer? That's cardioid. The curve is r equals a 1 plus cosine theta in polar coordinates. an epicycloid traced by a point on a circle rolling around a second circle of the same radius. Its single cusp and heart-like shape give it the name cardioid. A lemniscate would be a figure 8, and a general limosone can have an inner loop. Which mathematician, best known for a theorem linking continuous symmetries to conservation laws and for founding modern ring theory, is portrayed here? Take a look. A. Emmy Noether, B. Sofia Kovalevskaya, C. Marie-Sophie Germain, D. Hedvig Kohn. Stay calm, no panic. I'm counting 14 seconds. No more waiting. Correct. Precisely, Emmy Noether. The photograph shows Amelie Emmy Noether, 1882 to 1935, a German mathematician whose work in abstract algebra founded modern ring, ideal, and module theory. Her 1918 theorem, now central to theoretical physics, establishes a correspondence between continuous symmetries of a Lagrangian and conservation laws. Which early 20th century mathematician, famous for prolific self-taught work on partitions and modular forms, is portrayed here? Options: A. Aryabhata, B. Srinivasa Ramanujan, C. Bhaskara II, D. Subramanian Chandrasekhar. Sounds easy, but don't rush. You have 14 seconds. Timer starts now. Cards on the table. The answer? It's Srinivas Ramanujan. The photograph shows Srinivas Ramanujan, 1887 to 1920, the Indian mathematician who, largely self-taught, sent astonishing identities to G. H. Hardy at Cambridge in 1913 and produced foundational work on partition functions, Mach theta functions, hypergeometric series, and highly composite numbers before his early death. The clip zooms continuously into which fractal set? Choose A. Julia set, B. Newton basin, C. Buddha-Brot, D. Mandelbrot set. Easy to slip up here. 16 seconds on the clock. Go. The ones who picked it were right. Of course, Mandelbrot set. The clip shows a continuous zoom into the boundary of the Mandelbrot set. As magnification increases, the video reveals nested cardioid and bulb structures and self-similar mini-Mandelbrots, the signature of the Mandelbrot set's boundary. Julia sets, in contrast, are one-parameter slices with different topology. The Newton basin arises from Newton iteration. The Buddha-Brot is a Mandelbrot density plot. Place these four mathematicians in chronological order, earliest first. Your options: A. Isaac Newton, Euclid, Leonhard Euler, Alan Turing. B. Euclid, Isaac Newton, Leonhard Euler, Alan Turing. C. Euclid, Leonhard Euler, Isaac Newton, Alan Turing. D. Euclid, Isaac Newton, Alan Turing, Leonhard Euler. A classic everyone should know. That's 18 seconds. Timer's running. And the correct answer is... Yes, Euclid, Isaac Newton, Leonard Euler, Alan Turing. Euclid worked in Alexandria around 300 BCE, Elements. Isaac Newton lived 1642 to 1727. Leonard Euler lived 1707 to 1783, born while Newton was still alive, but his working career postdates Newton's death. Alan Turing lived 1912 to 1954. So the correct chronological order is Euclid, Newton, Euler, Turing. Whose imagined likeness is depicted in this 1908 illustration? A woman renowned as a mathematician, astronomer, and Neoplatonic philosopher in late antique Alexandria. What's it going to be? A. Theodora of Byzantium. B. Hypatia of Alexandria. C. Cleopatra VII. D. Zenobia of Palmyra. Now this gets interesting. 14 seconds to think. Start. Drum roll. The right one. Exactly. Hypatia of Alexandria. The illustration is Jules Maurice Gaspard's 1908 imagined portrait of Hypatia of Alexandria, circa 350-370 to 415 CE, a Greek Neoplatonic philosopher and mathematician who taught in Alexandria. No contemporary portrait survives. Gaspard's illustration appeared in Elbert Hubbard's Little Journeys to the Homes of Great Teachers, and is now the most widely reproduced image of her. What are the first 5 decimal digits of pi? The 5 digits immediately after the decimal point in 3. The choices: A. 14159, B. 14195, C. 14169, D. 14192. Think twice before you choose. Time, 12 seconds. Don't stall. Moment of truth. The answer? No doubt, 14159. The mathematical constant pi begins 3.141592655897993, so its first 5 decimal digits are 14159. That is 14159. This is a stable, well-established fact. Final score. Add your points and comment your result. If that felt too easy, the next round will be less polite.